This is the fourth and final tutorial in this series, and we're going to be talking about how we can take the entire 3D world, the entire composition that we've created, and place it back onto a single two-dimensional texture. And one reason why one might want to do that is, say we've created a 3D world that we really like, right? Like we have a bunch of shapes, all of them have videos mapped onto them. There's some nice movement going on, and it's just like a good composition overall. And say we want to apply a shader to that. We want to be able to change the brightness and the contrast, or we want to take that entire composition and map it onto the texture of a new shape that we come up with. There can be many reasons why we might want to do that, but the bottom line is that we're going to use the jit.node object in order to do so. I have an almost empty max patch here. The only things that I've written before are the jit.world declaration with a context called RTM2 with a floating window and an auto handle, the toggle that's on, and the send draw for every frame. This should all be very, very familiar. Um, so the way I'm going to do this, I'm going to create two shapes, place them onto the screen, attach some video textures to them, and then take that entire composition and map it onto a texture and apply a shader to that. So let's get started with the shapes. Let's do some jit.gl.grid shape for RTM2. Excuse me. Let's go with a sphere for the first one. Sphere. Let's place it at 0, minus 0.5, and 0. And let's give it a scale of 0.5 all around. Alright, so we have the sphere, and I'm just going to copy and paste this and change a few parameters. Let's make the second one a cube. Let's place it at positive 0.5y and maybe give it a z as well, like a 0.2, and we can keep the scale the same. Alright, so we have a sphere and the cube. Let's open two video files and attach to them as textures. So jit.movie with a read message. And jit.gl.texture, which will need a name if we want to be able to apply it to the shapes. So that's name text1. Let's make sure to set up the output texture1 parameter for jit.movie. Let's attribute this first texture to our sphere, texture text1. We see it as black right now because we haven't read our movie file yet, but I guess we can just put this something random. All right, so we see our first file playing on the sphere. Let's do the exact same thing for the cube. I'm just going to copy and paste this code, change the name of the texture to texture2, add texture2, texture text2 to our cube, and read a second video file. Something like this should work. It doesn't really matter that much. All right, great. So now we have this wonderful 3D composition, and we would like to apply a shader to it. So this is where the jit.gl.node comes into play. And I find that the easiest way to think about this object is to kind of consider it similar to how jit.world is creating a window for us, right? Like we have this RTM2 window. However, jit.gl.node is creating a window that's sort of not visible to the user. Anything that you can draw onto a jit.world window, you can draw into a jit.gl.node, except that it's just kind of stored inside of the GPU's memory, and we can bring it back and use it and display it on the screen whenever we want to. So in order to set it up that way, we need to tell it that it lives in the RTM2 jit.world, and we need to give it a name, and I'm just going to call it the node. And now using this name, the nodes, we can actually change the first parameter in the shapes that we've set up so that they get drawn inside of the node rather than inside of the main world. Nothing really changes on the screen right now, but let's just keep it that way for now, right? So the sphere is drawn onto the nodes and the cube is drawn onto the main context. Um, we can change where the node is being drawn on the screen. So if we use the position attribute and if we say 0.3 on the x-axis, 0 and 0, we see that the sphere actually moved to the right, showing us that it's actually getting rendered on the node. I'm just going to keep it at 0, 0, 0, in fact, and move the cube onto the node as well. All right, so now we have both objects drawn onto a node rather than in the main window. However, the node by default gets drawn onto the main window, so we haven't really done that much yet. In order to get this node to be drawn onto a texture, we need to use an attribute that's called capture. So I'm just going to say capture 1. So we need to set the capture attribute to 1 in order for that to happen. Connect it to the node. And the moment I click this, the screen is going to become empty. And that is because now the output of the node is not being sent to the screen anymore, but rather to a texture that we need to manually process and send to the screen ourselves. So we can just create, we can pass it onto a jit.texture object. We can give it a name, node texture. Oops, that's jit.gl.texture. Pass it here. And then there's a few ways that we could display this texture. We could map it onto a piece of geometry, or we could use a video plane. And I think I'm just going to use the video plane for simplicity at this point. So jit.gl.videoplane. Oh, we forgot to tell the texture that it lives in the RTM2 world. And the video plane does too. And if we connect our texture to the video plane, it's going to get displayed in here. And it's a little bit stretched, but that's okay. We don't care that much about it right now. All right, so let's do one more thing. Let's apply a shader onto this texture. And in order to do that, we use the jit.gl.slab object, gl.slab, which lives in the RTM2 world, and we can use the Brocosa shader again, cc.brocosa.gxs. We can give it let's adjust the contrast this time. Contrast $1. Connect it here. Okay, and let's add a variable to control the contrast. It's going to be float. All right, and now we need to rearrange our to introduce the texture into our the shader into our flow. So we can just drag it in between the texture and the video plane. So we send the texture into the shader, and then the result of the shader back into the video plane. Now we should be able to adjust the contrast for the entire image that was captured in the 3D scene, right? All right. Maybe we could do one more thing where instead of displaying our video texture onto a video plane, we map it onto a new piece of geometry. Let's say we define a new sphere and then we place everything onto that sphere. So let's create this sphere, jit.gl.grid shape, which lives in the RTM2 world this time. Shape sphere, position 0, 0, 0, and scale, let's say 0 0.8, 0 0.8, 0 0.8. We're going to give it a texture as well, but first we need to remove the video plane, and we need to send the result of the shader into a texture that is named. So we can call the name in the grid shape object. So I'm going to create a new jit.gl.texture, which lives in the RTM2 world, and the name is going to be node texture with shader. This is going to come in here. Maybe you observe that this texture now becomes a little bit redundant, right? Like we're not using node texture anywhere, so we could actually just remove it and connect our node straight to the jit.gl.slab object. All right, and now we just need to attach the newly created texture onto the sphere. So we're going to say texture node texture with shader. And now we should see our video playing mapped onto a sphere, and we have control over the contrast.